So now we're going to start off with trigonometry, and it is not as difficult as P1 trigonometry is not as difficult as compared to P3 trigonometry. Although that is relatively easier, the difficulty level increases as when you pair it up with integration and differentiation. That is when the difficulty level peaks. But before that, it's really easy. Because we are beginning trigonometry, we can begin with a very simple concept, which is your what you may call this. Mm, So this is A, B, C. Okay, this is a triangle, whatever. And we already know that for right angle triangle, this is like very easy and very common that you're going to have sine of any angle theta is going to be equal to perpendicular, or what you may call um, opposite over hypotenuse. Just give me a moment. All right. So if you have parsa, for example, sine theta is equal to perpendicular over hypotenuse. So what is going to be the case is that you're going to have it's very simple. And Assalamu alaikum, Naufal, how are you?
Walaikum
And
salam, sir.
Naufal, do try to be on time.
I thought class was at 5:15 today
Why?
because I think last link was sent at 5:15, so I thought today
Okay,
was at 5:15.
Naufal, sometimes what happens is that I begin the class and then send the link because I forget. All
Yeah,
right.
because I thought at 5:15, so I joined it directly, exactly 5:15.
Mm-hmm. Yeah, I noticed that as well. Okay, Naufal, the class is at 7. Sometimes what
Okay.
happens is that I 5:15 at your place, like 5 at
Yes, so
me.
like yes.
So the problem is that, sometimes I get late. I start late, or, I'm trying to set up the recording. That is why the
Hmm.
class begin. Technically, the class should begin at around um
7
5.
p.m.
Yeah, 7 p.m. my time, 5 p.m. your time.
Yeah.
And which is like 6 p.m. Parsa's time, right, Parsa?
Yes.
So, Nofal, we've just begun trigonometry, and I'm just trying to bore you guys with this basicity of it, like the very basic adjacent over hypotenuse. We did that, some people have curly brown hair, and some students do the Soka I think. Have you guys done that? I think so. I think you guys have probably done that. So yes, that is the case too. And then lastly, you have tan theta is equal to what you may call opposite, or you can say perpendicular over base or adjacent. So it's going to be this guy, this guy. So yes, the base over this. Is this clear?
Yes.
Any issues with this? Like this is come on, guys. Like this is even telling you guys this is a bit too basic. This is what we've done throughout. And it's only for right angle triangle. So for example, any triangle, any theta is going to give you um what you may call sine cos tan of theta is going to be respective of with respect to that angle. So the sides with respect to the angle. And your sides are always the opposite sides are always corresponding to the angle. Okay. Okay. And we also know that our Pythagoras theorem is hypotenuse is equal to hypotenuse squared is equal to the sum of the other two sides squares. Clear? Usually the triangle is like this. Clear? Now what's going to happen is that, oh yes, a bit of Pythagoras theorem as well, because I'm not going to risk the fact that you guys might have forgotten it, although I think it's a crime to forget this. Pythagoras theorem. And this is equal to a squared plus b squared is equal to c squared, which is considered the hypotenuse. Clear, guys? This is stuff that you've been taught already, like very basic stuff that we've already gone through with. All right. Now what's going to happen is that graphs. Now graphs are very important. And in order to do graphs, I'm going to endorse my app again, which you guys might think that I'm paid for.
That's
So
nice.
yes, person. I don't know why I really like this app. I did not have it when I was your age, so it feels nice to have this. Now let's look into the trigonometric graphs that we have. Now, first off, we are going to look into the graph of y is equal to sine theta. Now, these graphs are very important. The reason sine x as well, we can write it down like that. Now, the reason why these graphs are extremely important is because they are going to be tested both in trigonometry. They are going to be tested, sometimes tested in your coordinate geometry as well. And they're also going to be tested in questions which involve transformations. So the graphs are not really linked with your simple, what you may call trigonometry. They are linked with a couple of chapters. So that is why, I feel as if they are extremely important. Now, the domain of this graph, because this is a function, right? Y is equal to sine of x is a function. Let's write down its domain. So the domain of this graph is -1 and what you may call. So the values of sine x can only be equal to 1 and -1. Clear? And owing to this, let's continue forward with what you may call the graph. Now, my drawing is pathetic, but we will try to make something work. Mhm. So, I already know that my graph does not go beyond 1, 2, 3, 1, 2, 3, +1, -1. And now I'm going to be ultra professional today. I'm going to use a meter rule. Unfortunately, the meter rule is not no help at all. So wait, let me see how many intervals I need. I'm going to need 90, 180, 274 intervals. Okay, so it's going to be 1, 2, 3, 4. 1, 2, 3, 4. Alrighty. So we're going to have wow. Okay. And now I'm going to label it in degrees. So it's going to be 90, 180, 270, 360. Obviously, this little guy is 0. Then you've got minus 90, minus 180, all in degrees, minus 270, minus 360. Sort of like two complete rotations. Now, if you look at a graph, y is equal to sine x. Let me look at my graph. So one complete wave is ending at 2 pi and 0, and it is beginning from 0. And look at the 4 points. And it's in pi. So obviously, you already know that we've done radians above as well. That 1 pi radian is equal to 180 degrees. So at pi, this is pi by 2. Okay, this is at pi, it is 0. It begins from 0, goes up to 1 at 90, then goes back to 0 at 180, does a complete sort of like a rotation. So we can simply draw this graph as, wait, I need to, okay, it's all right. The graph is going to look a bit weird because the x-axis is too small and the y-axis is too big. But the graph is going to begin at 90 and go up to 180. And it is going to go up to 90. Oh, it's going to go up to 1 at 90. Secondly, what's going to be the case is that it's just going to be like this. Okay. It's a wave. But no matter what happens, the graph does not go below 1 or above what you may call 1. That is the domain of the graph. The graph does not exceed its domain. Is this clear, guys? The graph is always going to be like this. Has someone got their hand up? I think so.
Mister, can you repeat?
I was saying that because the domain of the graph is set, that is why the graph does not go beyond what you may call 1 and minus 1. A graph of just sine x is going to be a wave like this. Is this clear? So you can simply say that the cutoff points are these guys. My graph cuts off over here. It will not go above here. That is the, you can even say that's the range of my graph, but technically that's the domain. Clear? That's the you can say that that is technically the range of my graph. That is you're never going to get a sin x value above 1 or below -1. Clear? Anyone who does not understand this, let me know. This is, by the way, you should be able to understand this, considering the fact that you guys have done IGCSEs and O levels. And this is already taught there. Okay. Now, cos and sine graphs are similar. Like they're similar, not identical, similar. How are they similar is that simply what is going to be the case is that they're going to be what you may call cos x is equal to this is the similarity in terms of their range and domain, but the graph is a bit different. How is the graph different? Let's see. Now I'm going to cheat a little because the fact that my drawing is so perfect, I cannot afford to draw it again. Now, my graph for the cosine, for my cosine graph is technically the same, but there is one slight difference. And the slight difference is that it begins from what you may call, it begins from 1. So my graph is going to look like this. And it goes on from here as well. Like it should go on. Like this. Is this clear, guys? Similar to the sine graph, the only dissimilarity between it is the fact that it is not, it begins from 0. The sine one does not begin from 0. Is there anyone who does not understand this? Let me know.
Clear, sir.
Clear? Parsa, any issues with this?
No, sir, no issues.
It's like fairly easy, guys. I don't believe it should be a problem. All right. So keeping this in mind, now what we're going to have is you can look at the graphs orientation and the graphs itself, both of them. Why are they not responding the way I want them to? They move in a wave-like manner, but the cosine one, the difference between the cosine one is that it begins from 0. So it's kind of like it's behind the sine graph. It's following the sine graph. Clear? Anyone who does not understand this, let me know. Okay. Now, tan graphs are different, and we're going to take our time with them. They are slightly different. We already know how they're formed, but you guys need to further see them up. Tan graphs are probably the most different in all of these graphs. And they're also different in terms of their domain and ranges. That means that a tan graph stretches from negative infinity, tan x, to a positive infinity. Is this clear, guys? Your tan graph stretches out from negative to positive infinity. How do we construct the tan graph now? Let's look at it. So, first of all, can anyone tell me what are asymptotes? Yes,
Like, so they get close to a certain point, but they never touch it.
perfect.
Like, Mr. It's sort of like if you plot the graph 1 over x, you
Mm.
can't have x as 0 because it would be math error. So your graph, it would get so close to x equals 0, but it would never surpass it.
Kind of like touching infinity.
Yeah.
All right, kind of like touching infinity and beyond. All right. So my graph is going to be, still I can use the reference of one to show you guys what's the difference between the asymptote one and this one. So now I'm going to have the ruler again. Trying to be ultra professional today. So it's going to be the case that it'll be, I need my, what you may call, and on this side as well. So 1, 2, 3, 4, 5. There, guys. And at the same time, now what's going to happen is that I'm going to have these intervals at 90, and this is going to be, let's say, 180 and 270. So this is 90, 180, 270. Similar is the case over here. You're going to have 90 minus 90 minus 180 and so on and so forth. We don't need to know that. I'll draw asymptote lines, guidelines, such that these are now asymptotes are drawn at 90-degree intervals. Technically 180-degree intervals beginning from 90. So they are like this and like this. So how is your graph going to look like now? My graphs are, wait, we compare them with that. So y is equal to tan x. Look at the difference. Completely different. This looks weird. Oh no, I cannot expand it now. Yes. Look at the difference. Now, so it's going to be so it's going to be like this, such that your graph is going to be as close. Your graph is going to be as close as possible to your vertical intercepts, but it's not going to touch. This is just making my life so easy. The graph is supposed to be like this. Clear your tan graph. Now we can also extend it over here. Looks a bit weird without the extension. Mhm. Clear? That is how your graph it looks like. They're waves, but they are like sort of like you can call them strands of hair as well. They're like that. Anyone who does not get this can let me know right now.
No, sir, I get it.
Nofal, what about you?
I get it too, sir.
All
Clear.
right. Now what's going to happen is that you're going to have all of these graphs are also going to be tested in your exam as well. Like for example, if we look into your syllabus, sketch and use the graph for sine, cosine, and tangent functions for angles of any size using either degrees or radians. Now we already know what are degrees and radians. That okay, we can also write that down here somewhere. That 180 degrees is equal to 1 pi radian. So 180 is equal to pi. This is pi by 2. This is 3 pi by 2, 2 pi. Similar is the case with negative pi by 2, negative pi, negative 3 pi by 2, and negative 2 pi. All right. And that is the case throughout. So you're going to have what you may call, um, let us just, let me just write these down for, so it's going to be like this over here. Any issues with this, guys? Let me know. So your syllabus also wants you to make sure that whether it's radians or degrees, you're able to plot graphs and you're able to do transformations on them as well. All right, regardless of what the question may be. All right, and for any angle as well. But usually they tend to stick between 360, negative and positive. Basically, is this clear? Okay, now let's do a question as well regarding this. Wait, let me give you guys a question. Okay, guys, consider this question. Now I want you both to write down this graph, or oh, sorry, to draw this graph essentially. All right. Draw the graph of y is equal to 3 sine x. Considering the fact that the original graph is y is equal to sine x, so it looks like this. You guys want to draw the graph of y is equal to 3 sine x. All right. Then I'll do it, and then you guys will guide me through it. Okay. All right. Let me know when you're done.
Oh, wait, so what's the question again?
This is the question, person.
Oh,
Draw the graph of this.
okay. Okay, so I sketched the function.
What about you, Nofal?
Yes, sir, done.
All right. Okay, let's see. So your original function, why did I erase those? Wait, I can keep the y is equal to sine x1. So y is equal to 3 sine x. Now, this is what I think I told you guys above as well when we did transformations. I told you, no, this is discriminant, sorry. Where did transformations go? That whenever you're multiplying with something outside the entire function and the entire function is being multiplied with it, it increases or decreases the amplitude of the curve depending on, if the number is bigger, it's going to increase the amplitude. If the number is smaller, it's going to decrease the amplitude. The reason for that is that these were written because of the fact that trigonometric graphs undergo these type of rules. So what's going to happen is that if I copy down this entire graph, my newer graph is just going to be an extension of this one. Extension of this one. How so? That is the amplitude, nothing else is going to happen to the graph. The amplitude of the graph is going to increase. So it's going to become 1, 1, 2. This is 2, and 1, 2, 3. Similar is the case over here. So it's going to become -2, -3. And my graph is simply going to extend beyond this. So my graph is going to go like it's just an extension of the already drawn graph. Like this. And then just simply I can copy this guy down. Nothing else is going to happen to the graph apart from the fact that it's just going to extend above or go above what you may call your transform graph is going to be just greater in magnitude. All right. Now I'm giving you guys 2 questions as homework. Wait. Yes. Or you can do them right now. We still have time. I just looked at the watch. So those 2 questions include Hmm, just give me a second. So we've got these 2 questions. And the second one is, second example that I want you guys to do is, now a few more transformations, combined transformations. Y is equal to 1 minus cos 2x. And then I want you guys to do y is equal to, okay, just do this one for now. All right. Now do this one, guys. You already know how the y is equal to 3 sin x is going to look like. Do this one and let me know. All right, guys, you can do this till the next class. I'll check it in the next class. All right. Kindly complete it till the next class is over.
Oh, wait, Mr. Can you please scroll up again?
Yep. Should I
Oh,
zoom
okay.
in? All right.
Okay. Thank you, Mr.
Keep smiling.
Thank you, Mr. You too.
Love is. Bye bye.
You, Mr. Take care.